How you guys doing? As you guys know, I'm out here today. Hopefully, today's lesson that you guys can get pretty much material that we went over yesterday. If you have questions, hopefully when I go over the homework, you guys understand it. So, let me tell you what we're going to be doing today through this video right now. First of all, we're going to go over the homework. Secondly, we're going to do a review of yesterday's lesson. And if you guys totally understood yesterday's lesson, you can immediately start tonight's homework. So, again, we're going to go over the homework. We're going to review yesterday's lesson. And then you guys can start on tonight's homework. So let's get going with the homework from last night. Last night's homework, you had to do page 415 to 416, written numbers 1 through 23. I know the last 4 or 5 might have been kind of tricky and difficult, but hopefully throughout the lesson or when I go over the homework, you guys can understand it better. Remember, guys, that whenever you guys have questions or need for me to slow down, you can obviously just press pause on the YouTube lesson before I go on. So here we go. So number 1 should have been pretty simple. What you want to do is graph both of these lines. So I'm going to graph the first one, y equals x. That gives me this line. For the next line, because I don't like how it's arranged right now as y equals 6 minus x, I rearrange it as y equals negative x plus 6. Once I rearrange it like this, I can then graph it. So it's a lot easier because I know the slope and I know the y-intercept. So as you guys know, throughout the lesson, what we want to find is the intersection of both lines. It's called the system of equations, and our goal is to find the intersection of both lines that fit both equations. So the answer for number 1 should simply be 3, 3. And if you plug 3, 3 into both equations, it should both work. For number 3, I just simply have to graph them. It's pretty easy. For y equals negative x plus 2, it gives me this graph. For y equals 2x plus 5, it gives me this graph. So where do the two lines intersect at? They intersect at negative 1, 3. And that's the answer. For number 5, I have to do some manipulation here. If you look at number 5, they're both in standard form. What I want to do is to get both equations into slope-intercept form. So for the first equation, x minus y equals 6, I subtract x from both sides, and then I divide both sides by negative 1 to get y equals x minus 6. I then can graph this to get this line. For the second one, it's a little easier to manipulate to get to slope-intercept because all I have to do is minus 2x from both sides. And I get y equals negative 2x, and it gives me this line. So where do both lines intersect at? They intersect at 2, negative 4. For number 7, 3x minus 9y equals 0. What I want to do is subtract 3x from both sides, divide both sides by negative 9, and now it's a slope-intercept form. And my line will look like this. For the next one, negative x plus 3y equals negative 3, I want to add 3 to both sides. I then divide everything by 3 to get y equals 1/3 x minus 1. If I graph this line, it should look like this. What do you guys observe about both lines? They're both parallel. So if two lines are parallel, they do not intersect. So what is our solution for these lines? No solution. There's no intersection, therefore there's no solution that fits both equations. For number 9, I can easily graph the very first equation because it's in slope-intercept form. Y equals 1/2 x plus 1 gives me this line. For the next equation, it's in standard form, so I have to change it to slope-intercept by first subtracting 4x from both sides. I then divide both sides by -8. So y equals 1/2 x plus 1 again. What does that graph look like? It's basically the exact same line. So when you have something that looks like this, when you have a graph over a graph, it's basically the same line. So what's the solution for both equations? It's all real solutions. When a line is basically on top of another line, it intersects at all points, really, and it's all real solutions. For number 11, very similar to what we saw before. Try to get y by itself. So y equals 2x minus 5 for the first equation. For the second equation, I get the equation of y equals x minus 3. So where do both lines intersect at? At 2, -1. For number 13, very similar to what I've done in the past, I want to get both equations into slope-intercept form. So for x plus y equals 3, I subtract x from both sides, and that's my equation that I'm going to graph. For x minus y equals 4, I'm going to subtract x from both sides, divide both sides by -1, and that's my equation of this line, y equals x minus 4, which then gives me this line. So according to the instructions for number 13, you have to estimate the best of where both lines intersect at. And as I said in yesterday's lesson, you have to be very, very accurate when graphing your lines so you can find the intersection. So from what I have graphed, I can estimate that the lines will intersect at 3.5 and -1/2. You might have gone something a little different if you did not graph your lines very accurately. For number 15, same thing we've done before. Get y by itself and write the equation in slope-intercept form. So subtract 3x from both sides, divide both sides by 5, and that's the equation in slope-intercept form for the first equation. And it looks like that. For the second equation, subtract x from both sides, divide both sides by -1, and that's the equation in line for that. So where do both lines intersect at? Again, you're the best estimate after you've drawn both lines accurately, and if you can see through mine, I can estimate that both lines intersect at 4.5 and 1/2. For number 17, all you had to do is really see where both parabolas intersect at. They both intersect at -2, 4 and 2, 4. And really what they wanted you to do is to see if both equations work into both equations. Both coordinates work in both equations of the parabola. And they do. Now, starting with number 19, this is where it gets very, very tricky. Number 19 says, where on the graph of 5x minus 2y equals 15 is the x coordinate equal to the y coordinates? So what I'm going to do here is actually set up two equations from the information in number 19. I'm going to first write out 5x minus 2y equals 15 and graph that. I subtract 5x from both sides, divide both sides by -2, and I get this equation of a line. And remember, it's kind of difficult, but you got to try your best. How do I do the y-intercept of 15 over 2? Well, that's 7.5. Negative 7.5. And the line will look like this. So where is my second line coming from? My second line is going to be coming from the information in number 19, where it says the x-coordinate is equal to the y-coordinate. How would I write an equation for that? Well, does that basically mean y equals x? Can you draw a line for y equals x? Yes, you can. It looks like that, where the slope is 1 and the y-intercept is 0. So if you look at my graphs, where do both lines intersect at? They intersect at 5, 5. And 5, 5 fits into both situations. It fits into 5x minus 2y equals 15. And also fits the situation where the x-coordinate is equal to the y-coordinate. For number 21, it says where in the graph of 4x plus y equals 12 equals 0 is the y-coordinate twice the x-coordinate? You're going to do the same thing. I'm going to first try to graph 4x plus y plus 12 equals 0. In order for me to do that, I have to get y by itself, and I get y equals negative 4x minus 12. Since I have a small graph, I'm going to kind of fudge it here, guys, and really estimate where negative 4x minus 12 would be at. It would be this line. But since you guys have more paper, more room on your notebooks, it should actually be negative 4x minus 12, where the y-intercept is at negative 12, and the slope is at negative 4. Now, the next equation fits the situation in problem number 21, where it says the y-coordinate is twice the x-coordinate. So how would I write that out? It would be simply y equals to 2x. The y-coordinate is twice the x-coordinate. I then just have to graph it. Y equals to 2x gives me that line there. So where do both lines or situations cross at? They cross at negative 2, negative 4. And it does fit into both equations or situations. For the very last problem, number 23, find the area of the triangular region enclosed by the y-axis and the graphs of 6x plus 5y equals 30 and 2x minus y equals 2. This is the hardest problem, and I'll try to go over it as clearly and as slowly as possible. So eventually, this situation will form a triangle. But the first thing I'm going to do is graph 6x plus 5y equals 30. Like I've done throughout the whole entire homework, I want to get y by itself. I first subtract 6x from both sides, and I then divide both sides by 5. So I get y equals negative 6/5 x plus 6. The y-intercept is at positive 6, and my slope is negative 6 over 5. And the line looks like this. The y-intercept is at 6, and the slope is negative 6 over 5. I then want to graph 2x minus y equals 2. In order for me to do that, I have to get y by itself. So I subtract 2x from both sides. I then divide both sides by negative 1. So the equation is y equals 2x minus 2, where the y-intercept is at negative 2 and the slope is 2. And that line looks like this. So again, the triangle is in between the y-axis and the two lines that I just drew. So it looks like that. That's the triangle they want me to find the area of. How are you supposed to find this area? Well, if you don't remember what the formula of a triangle is, it's 1/2 base times height. And in order to figure out the area of this triangle, you're going to have to look at this triangle sideways. So tilt your head to the right. So that measurement right there, it becomes the measurement of the base. So how many spaces is that? That is 8. If that's the base, this is the height. What's the distance or measurement of that? If I graphed it accurately, I should have gotten the measurement of 2.5 or 2.5. So I know the base of the triangle, which is 8. I know the height of the triangle, which is 2.5. I then can find the area. The area of the triangle is 1/2 base times height, which is basically 1/2 times 8 times 2.5. If I multiply everything out, the area of that triangle is 10 square units. Now for yesterday's lesson, we did 9.2. This is what we did on the second